So my name is Martha. I'm a software engineer at Uber, which is a company in San Francisco that dispatches cabs and other vehicles to your location. I work with JavaScript primarily, but I do both client and server-side JavaScript, but I also like Python a lot. But the title of my talk is the JavaScript interpreter interpreted. But that's kind of a trick. I'm not really particularly interested in interpreters or compilers. I'm really more interested in how the ECMAScript specification requires the interpreter to process your JavaScript. I like to remind myself of this every once in a while. Software's primary technical imperative is, does anyone know? Any takers? Software's primary technical imperative is managing complexity. And either fortunately or unfortunately for us, JavaScript is kind of complex. It kind of deviates from some of the paths well-worn from other languages. So in order to manage the complexity of JavaScript, I kind of like to dig into the specifications and figure out why things are complex, or try and reduce the magic so that I actually understand them. But I actually grabbed this little quote from a book called Code Complete, which I highly recommend. It's by Steve McConnell. So JavaScript is usually interpreted, but not always. And in case you aren't familiar, when something is interpreted, it means that your source code, which is your JavaScript code, is parsed. That is turned into an abstract syntax tree. That is generated into bytecode, and that is interpreted into machine code, which is just binary that runs on your machine. So note, I say that JavaScript is usually interpreted because in JavaScript engines like V8, it's not interpreted. It's actually just converted directly into machine code. But like I said, I'm not exactly really interested in that. I'm more interested in the mechanics of JavaScript itself. OK, so the thing about JavaScript is it's really wonderful. Nearly everything is an object. That makes it incredibly flexible and extensible. And even better, I think, is that functions are first-class objects. So that just means that functions can be stored and referenced in a number of ways. Some of these, or actually all of these, are functions can be stored inside variables. They can be applied to objects as methods. They can be stored inside arrays. They can be passed as arguments to other functions. And they can be returned as values from other functions. Considering that functions can do so many things, I'd say to understand JavaScript, it's pretty imperative that you understand how JavaScript itself creates and executes function objects. In fact, I'd say that everything about your understanding of JavaScript hinges on this. So the thing about function objects is that they have two stages. They have a creation phase and an execution phase. And they're distinct, and distinct things happen during each phase. So in the creation phase, this is when your function has been invoked but not yet executed. And during this phase, a bunch of magic happens, which we'll go into more detail. But within that magic, scope is determined and context is determined. And then and during the execution phase, your function is just run. So when a function object is created, it's all dependent. All the values that are determined within that function are dependent on the execution context. All JavaScript code that you write is evaluated through an execution context. And basically, lucky for us, there are only 3 of these possible execution contexts that any of our JavaScript code can be run through. The first one is global. The second one is function, and the third is eval. And we're not really going to focus on eval because it's not entirely practical. And just as a little ranty side note, I don't think eval is inherently evil. It's just inherently dangerous. But regardless, we're not really going to talk about it. So whenever the browser first loads your script, it enters the global execution context by default. And then from then on, every time a function is invoked, it enters a function execution context. And that actually also applies if a function were to call itself recursively. Each time that it calls itself, a new function execution context is created. Execution contexts form stacks. JavaScript in the browser is implemented as a single thread, and that means only one thing can be executed at a time. So all the execution contexts are queued. So the first execution context to be added to the stack is the global. And then, like I said, each time that a function is called, its function execution context is pushed to the top of the stack. And when it finishes executing and it's completed, it is popped off the stack and relinquishes control back to the one below it. Yeah, and most of my examples involve cats or girly things. Deal with it. What really is an execution context? If all of our code is evaluated through it, really what is it? I like to conceptualize it as an object. It's not an actual object. It doesn't have a prototype. It's not immediately accessible in your code. It's just kind of like a construct of the language. But I like to visualize it as an object. And basically, it stores three things that are relevant to the particular context, whether it be global or function. It contains something called a variable object, which the variable object holds references to all the arguments passed to the function, all the internal variables declared within the function, and all of the functions declared internally within that function. The scope chain is defined within an execution context, and basically it's just a chain of objects that are in scope for this particular context. But we will go into more detail. Sorry if that was vague. And then the third thing the execution context contains is the value of this. And the value of this is defined based on the context that this function is being created and executed in. And we will go into more detail about that as well. So the first thing that I'd like to go deeper into is the variable object inside this execution context. Basically, when your function is created, a variable object is created, and within it is a property called arguments. And it will hold a reference to all of the parameter names and argument values that are passed to this particular function. So that's why if in your code you've realized that you can access this arguments keyword. That's why, because during variable instantiation, when your function object is being created, this property is added and available to the entire body of your function. So the next thing that happens is it scans your code for all function declarations, and it takes the name or the identifier of that function, pulls it up into this variable object, and then it sets the value to this a pointer to the function object itself. So the third thing that it does is it scans your code and finds all variable identifiers, hoists them up into this variable object, and it initially assigns them all as undefined. That is critical. So one thing to note is if a function name exists already, the reference pointer value will be overwritten. If a variable name exists already when it's scanning, the variable, it will actually do nothing and continue scanning, because like really what's the point? It's just going to define it as undefined anyways. OK, so here's an example of hoisting. Earlier when I said that when variable identifiers are pulled up into this variable object, they are initially assigned as undefined. That's because the actual definition or the value that's assigned to that variable does not actually get applied to that variable identifier until execution. So that means until the actual code has processed the part of your program where the equal sign assigns the value to the variable name. So the very top of my kitten function, I'm logging mu before I've actually defined it. So in the function below it, I'm actually showing like conceptually what the interpreter really thinks, or what is actually happening behind the scenes. So it's scanning your code, it's finding the variable mu, pulling it up as undefined. Your console logging at that point, mu is undefined. Then in the next line, mu is defined as a string mu. At that point, the actual value that you're anticipating is assigned to the variable. But another just interesting thing, if you notice, it doesn't log like reference error. It's not saying this variable doesn't exist anywhere. It's just saying the actual value of this variable is undefined. And that's because of hoisting, if you've heard that term. And I really just wanted to drive this home, so I put this up as a slide. The properties created on the variable object for local variable declarations are initially assigned as undefined. OK, so then next thing I would like to talk about is scope. So despite JavaScript's C-like syntax, JavaScript does not have block-level scoping. And that's because scope is only defined at the function level or the global level, but more commonly we interact with it at the function level. So scope does not exist in the context of like an if block or a for loop. It only exists when the function is created, and that's when it's assigned. Scope is actually a chain of objects. And what's interesting here is when scope is defined, when your function object is being created, the first entry in this chain of objects is the most immediate variable object. So all of the variables and function declarations that were defined within this function are first. And then it actually holds an external link to its parent's variable object, which in turn, the parent would hold a link to its parent's variable object. And this will just go all the way up until you hit global. So that's why in any inner functions that you have, you can reference things stored inside the global object, because it holds a reference to this chain of scope that traverses all the way up to the global object. But that's also why a global object could not reference anything inside of an inner function. It does not have that ability. And that's also why in JavaScript, globals are implicit. So identifiers. Identifiers are just names of properties, variables, functions. And when I say resolved, I just mean like if inside of your function you're like, I want to find some kind of value with the name of kitten, it's going to look up the scope chain for all identifiers that equal that same name of kitten. And if it doesn't find it in the most immediate scope, like in its variable object, it will look up the next level up into its parent's variable object. If it doesn't find it there, it will continue looking upwards until you hit the global object. And if it doesn't find it then, it will just resolve as undefined. And one thing to note is, so identifiers are resolved against the scope chain, but this, which is a keyword, is not. This is not an identifier. This is a keyword. So this holds a reference to the object that the function is being applied to. That's the simplest way I can think to word that. So this does not necessarily mean that this will equal the object where the function is stored. OK, so to go any further, if you're going to understand my next example, you need to go to YouTube and look up Bee and Puppycat. This is like an anime. It's like a short. It's like 10 minutes long. I'm entirely obsessed with it. So here I have a variable named B. I'm setting it equal to an object with one property, value of string B. Doing the same thing for a variable puppycat, setting it equal to an object with one property name, and its value is puppycat. So on my first object, I'm adding a method, and all it just does is return hi, and then whatever the value of this, whatever the property name is on this at that point. So in the last line, I'm doing something like wholly confusing, but JavaScript lets you do that. I'm creating a new property on my puppycat object, and I'm setting it equal to the method that I already defined on B. So what would this refer to in this context? The important thing to remember is it's not where the actual keyword this is stored. It's stored in B as a method on the B object right now. But actually, this corresponds to the object to which it's applied. So right now, it's actually applied within the context of puppycat, not within the context of B. Whenever I'm like writing really complicated JavaScript and I get a little lost, I use these 3 points to kind of guide me through. If you're at a top-level function, if it's not contained by any other function, the value of this will resolve to the global window object. And there's actually a really interesting reason why. The global object, or when your script is first processed by the browser, the global object goes through variable instantiation just like a function does. So that means all the top-level variables, all the top-level functions actually are added as properties and methods to the variable object of the global object. So I know it sounds like crazy, but really, if you're inside of a function that is a top-level function, and you reference the this keyword, at that point, it's technically, like that function is technically a method on the global object. And so if my second point is correct, where if you're inside of a method, the value this points to the object into which it's applied, well, then a top-level function is actually a method of the global object. So this points to that object to which it is applied, which is the global object. So sorry, it's kind of confusing. But then the third point is a constructor. If you have a constructor and it generates objects, the value of this refers to each individual object, not the constructor itself. Oh my God, closures. This is often complicated, or I don't know, it was very complicated to me when I was first learning like programming or JavaScript in general, and it doesn't have to be. There's also a lot of really terrible information on the internet about what a closure is. But to put it as simply as I can, a closure is created when a function remembers the variables in its scope when it was created. So when a function is created, it stores an internal reference to the variable object of itself and of its parent. So technically, anytime a function is created, a closure is formed. Now, whether you choose to actually return that value or not is up to you, but returning the value, returning those variables that were in scope when the function is created, that's not what makes a closure. Of course, it's like probably way more useful to return it. So this is a lot of text. I'm so sorry. But basically, I'm just showing how you can store something secretly within a function, return other maybe methods that like operate on that secret data but doesn't actually reveal the secret data itself. So here I'm just kind of creating a little game called Find the Kitten. You're guessing where it is. But the secret is actually like obfuscated from the actual function once it's been invoked. Like at that point, it's just an object. You're just returning this object with this like guess method, and really that's it. So yeah, so the guess method is actually able to operate on the secret because it's within its variable object. It's within scope of that object. And that's how that you can actually like play with the secret, whatever the secret variable within the find the kitten function. So I blew through all of my slides so quickly. I do this every time. But hopefully now you know more about how JavaScript works. I am so happy to take questions. And I also have a challenge for you, 2 challenges. Please follow me on Twitter. I really like talking with people on Twitter. And also, if you can think of something totally like weird to endorse me for on LinkedIn, I will be forever grateful. But yeah, but I'm also questions, or find me afterwards, or we could just all go get coffee. I'm fine with any of that. Yeah?
When a closure is created, does it, correct me if I'm wrong, I think it only references variables that are used within that function, not all variables from earlier cases?
Yeah, that would definitely be more concise. Okay. Yeah, this was, I should have like totally had some kind of disclaimer that like all details have been glossed over. All of them. I was trying to like cover as much like or some of like the pain points either I've felt or other people that I'm teaching JavaScript have felt. So yeah, I would absolutely read the specification if this is the kind of thing you nerd out about. Yes?
This isn't a question so much as a suggestion, but since you say you're trying to go over pain points, one that I find that people run into all the time with JavaScript is variable hoisting, where all of the variable declarations, no matter where they are in your function, end up basically interpreted at the top of your function.
Oh, I did cover that. Yeah. When the variable object is created, or when your function is created and the variable object is starting to define values within it, it scans all of your code and it takes all of the variable identifiers up into it as properties, but it assigns them all as undefined. So yeah, so that's essentially like it pulling, I guess like we're conceptually like pulling all of the variable identifiers to the top of the function definition. But really it's this variable object that's just kind of like available to, like globally or locally available to your entire function. But yeah, totally. It's weird. Any other questions? No? Okay, well, please come find me afterwards if you would like to chat more. Oh, yes, hi.
Can we watch V and Copycat?
Do we have time? I don't have audio set up. You may have to come help me. I am helpless.
This is your audio.
Ah, okay.
Is your plug here on this side?
I don't actually know. It is on this side.
Right here. Does it reach?
Oh, yeah.
I jaywalk, but I can't afford getting a ticket.
No.
Change, you stupid white. A cat? Maybe a dog? Huh. Gah. 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 I'm such a loser. Ooh. My guts, my guts. Coming.
Hey,
Hey, Deckard.
I heard you lost your job?
Oh, yeah. Too bad I can't make a career out of getting fired, right? It'd be like a CEO or a manager. Which one's more impressive? President?
Are you gonna be okay?
Oh my God! Oh my God! Wait! I have stuff for your stuff! I got you some ice for your crotch! I'm shoving this crotch ice under the door! Oh, you're awake. Want to split a casserole? Ah, hello. Well, well. What? Ah, wait! Where are you guys going? Why does this make me feel so sad? Ah, my dream! Ah, you were there! Ah, lasagna's gone! Hmm? Ah, I'm late! Ah!
Okay, you have no documentable skills. You didn't manage to finish schooling past high school. Work history, spotty at best. This is a temp agency, not a charity. Hello? Uh-huh. No. Well, I didn't know that he had a peanut allergy. Okay, well, you know, if it's just a little bit of swelling, then just get him away from the peanuts and it'll be over in about a half hour. Otherwise, call an ambulance. Thank you. Yeah, bye.
You took too long. Now your candy's gone. That's what happened. Pow!
No, thank you.
Hey, dude, I got you presents. Pet store I used to work at is going out of business. Lucky us. So, let me see. I got you a bone and wrapped a toy mouse around it, a blanket, eggplant pillow, dog food, cat food, shampoo, a leash, and rain boots. Yeah. Crap, I ran out of food money. Relax, man. I'm not gonna eat your food. Stop! No hitting. There better not be anything scary cryptic written in here. I will scream so loud and then totally lose my marbles. Pretty stationary, though. Dear puppy cat, is that you? Please report to Fishbowl Space for temp work. Sign below. Oh, let me get you a pen. Ah.
Hello? Hello? Anybody here? I've been left behind. I'm all alone. Am I not good enough? Ah!
Incoming. Welcome, puppy cat. You look different. And hello, unrecognized intruder. Unfortunately, due to increased security measures, you must now be incinerated.
Whoa! Hey, you talk! Kind of.
Oh, like a trainee shadow. Welcome. Initiating uniform assignment.
No. I don't like this outfit.
Please proceed to Fishbowl Space. Let me know when you're done.
What are we doing? Hi, Wallace. What's wrong?
I miss my mama. She's been gone forever.
Aww. Do you want something to drink?
No, thank you.
You want a snack?
No.
You want a nap?
No.
He's so sad.
Can I have a story? And then what? That's your ending? That's awful and very interesting.
I knew it was you, pretending it's just a fairy tale, lying to children, making them look up to a hero. Who, in reality, is just an awful monster.
Ah, sick! Puppy cat! Let him go! I'm gonna kill you! La 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 la! Don't tell me what to do! Wow, wow, wow! Okay. Why? What's that gonna do? Whatever. Whoa! Jeez! Hey, was that story you told that fish true? Oh, did you forget how to talk again? Oof. Oh my god, I'm so glad there wasn't anything sharp on my couch. Woo! Ugh. Wow! Hey! Cat Ash! Whoa, thank you! And thanks for not letting Tempbot burn me up. I think I'm gonna use my money to get Deckard a casserole, since he bought me a casserole. What you using your money for? Oh, ignoring me again? Fine. I liked your fairy tale, puppy cat. If you want, I can help you figure out a nice ending.
Yeah, but that's what I'm obsessed with. So I'm really glad you got to experience that with me.